Hey guys, welcome to Computer Science Fundamentals. I'm Ray. I'm going to be working through some recursion explanations and examples. I hope you guys are all comfortable, enjoying your lunch, and that you guys enjoy. So as I said, today I'm going to be touching on the basics of recursion, a crash course if you may like. Whether you are familiar with Java, Ruby, as we all are, thanks to makers, JavaScript or Python, the fundamentals of recursion are conceptually the same. I will work through a little bit of code in this video. I'll try and make it as language agnostic as possible, but do forgive the little bit of JavaScript that I'll be using. So jumping straight into it, the first thing that I want to explain is that recursion is just an approach to writing a solution. We can have any given problem, like something really simple, sum up all the numbers between 1 and 100. What most of us will do, including me, is use a loop, which means that you would write a solution in the iterative way, using iteration. But what you could also do is write a solution that refrains from using any loops, so it is not iterative, and instead is recursive. And that's what we're going to get into in this video, how that specific kind of approach works. Right, so to start us off, I'm going to tell a little story. And by the way, this is the way that Alice taught me recursion, and I have heard this story floating around, so it might be that this is a computer science fundamental lesson. So if you have heard of it, enjoy. So back in the world of some fantasy story, there was a boy named Martin and a dog, both symbolized by emojis over here. So one day, Martin was asked to go up to this dog and ask him whether or not any of these numbers were odd. Apparently, Martin and his mates didn't know what odd numbers were. Right, so Martin goes off and asks this dog, and the dog responds by saying that he will only tell Martin if the first number in this list is odd. Now, that's not what Martin wants. He responds, "No, I need to know if any of the numbers in this list are odd. Sorry, boy, I'll only tell you if the first number in this list is odd." Now the dog's getting a bit angry. So Martin sits down, has a think, and here's a solution. Right, fine. What about the first number in this list? The dog says, not odd. Then Martin comes back with a different list and asks if the first number in this list is odd. The dog again says, not odd. Martin does it again. What about this number? The dog says, not odd. One more time. Nope, not odd. Then finally Martin asks about the first number in this list. And the dog says that this is an empty list and that there isn't a number. Nothing can't be odd. And then Martin says, aha, so all the numbers are even in that list. Nothing is odd. And the dog says, I never said that. So Martin starts explaining. First, I gave you the whole list, and you said that the first number was not odd. Then I removed the first number and gave you a new list, and I asked, is the first number odd? And you said, not odd. I kept doing this until I gave you an empty list. So we know therefore that all the way up there are no odd numbers, and all that you have told me was that whether or not the first number was odd or not for a given list. So Martin heads home, a hero, and the dog congratulates him on discovering recursion. And Martin was a bit surprised because he didn't realize that the dog knew what was going on this whole time. And this is kind of why I like this story, because it's just an explanation of a more complicated idea, which I will start unpacking now. What is recursion? Recursion is a process, or in the context of code, a function that calls itself over and over and over again. It's important to know that it calls itself, and a function that calls itself, that seems a bit odd. This is how a recursive function works. All that you do is write a function that calls itself with a smaller piece of input each time, until you reach something that we call a base case. So in the example of Martin and the dog, Martin kept asking about a smaller and smaller list until we hit an empty list, at which point we were done. So it's important to realize that there has to be this base case. The base is where the recursion ends. So you call this function and it calls itself. But that can't go on forever. And we will see what happens in that case. It's called a stack overflow. It's basically recursive version of an infinite loop. So there has to be this rock bottom, and you have to hit rock bottom, and everything has to stop, which is where your base case is. So those are your two pieces. We have a base case, and then we have a smaller input, something that is getting us closer and closer to our base case. So this example is called countdown. It's a very simple function that allows you to put in a number like 4, and it's going to count down. So it would print 4, 3, 2, and then 1. Then it's going to print all done at the end. We have a recursive call right here. So our function is called countdown, and we're calling countdown inside of it. We have a base case, which is this if statement. This is checking if we have hit the end of our countdown, and if so, we're going to console.log all done, and then return. And I'll explain why that return is so important. So yeah, let's go and run this. Right, so here I've written the function up as a snippet in Chrome, and I'm going to call it and pass in 4 as num. So if I execute this, we get 4, 3, 2, 1, all done. So if we step through what happens, it looks like this. We call countdown of 4. This part does not run because num is 4, so we console.log num, so we print out 4. We can just show that here. Then we subtract 1 from num, so num is now 3, and we call countdown of 3, so we could basically write it this way. So countdown of 3, this does not run, and countdown is 3. And then we call countdown again on this line. After we subtract 1 from num, we're calling countdown of 2. So countdown of 2 is going to run. This is still false, so nothing happens. So we console.log num, and num in this case is 2. So almost there. Do the same thing again. Subtract 1 from num. So it's countdown of 1, which is 1 because this is still not true. So we finally print out 1. And then we subtract 1 from num. So num is now 0, and we're going to call countdown of 0. What happens now is we hit the base case. We're calling countdown of 0. So num is now less than or equal to 0, which means we console.log all done. And then we return. And return is going to end our recursion, because if we didn't have this return statement here, our code would just continue and would console.log num, and num would be subtracted by 1. And it would print it out, and we would continue to call countdown again and again until we land up with negative numbers. So if I remove that return, we can see what happens. Right, so I'm back. And that was just a recursive version of an infinite loop, and Chrome just manged out. So let's take a look at our second example. This one is called SumRange. Again, nice and quick, nice and small. SumRange is going to take in a number and is going to return all of the numbers between 0 summed up until that number. So if we pass in 3, it should return 3 plus 2 plus 1, which is going to be 6. So yes, technically it stops at 1, but if you add 0, it doesn't matter. Or if we passed in 5, it would be 5 plus 4 plus 3 plus 2 plus 1. And that's the way it works in this case. And I'm not using a loop, I'm doing it recursively. So if you take a look, can you identify the base case? And do you notice the different input? And what would happen if we didn't return? So we're going to start off with num equals 3. The base case will check, the base case check will happen, and it's not true because num doesn't equal 1. So instead we're going to return 3 plus some range of num minus 1, which would be 2. So then we're going to call it again, some range of 2. This is still false, so we return 2 plus some range of 1. And this time num equals 1, so we return 1. So I'm going to step through exactly what happens here. And if you are not familiar with the call stack, then I might have just given you an idea for your next talk. When we call some range of 5, for example, the very first thing that happens is that the base case checks returns not true. So we return 5 plus some range of 4. So some range of 5 is added to the call stack, but it doesn't know exactly what to do yet because some range of 4 hasn't returned anything. So it's waiting. So some range of 4 is called and then returns 4 plus some range of 3. And it's waiting. So we keep going until we get some range of 1, in which case num is equal to 1, so we return number 1. So this returns 1, which means that some range of 2 can now return its value because it was waiting. Which means that some range of 3, 4, and 5 can all return their values. So looking at the Chrome debugger now, I've written the code up and simplified it to be some range of 3. And if I execute it, we get 6. And here I've written up what it actually looks like underneath the recursive code. So if we step through this, and I'll add a breakpoint here on line 6 and execute our code, take a look at the call stack here. You'll see that the first thing that happens is the sum range is added. That's our sum range of 3 right here. And so it gets to this return num. So it's going to return 3 plus sum range of 2. And watch right here. You'll see that we get a new sum range added. So this is now added onto the call stack, and you can see num is 2 in this function call. So this is false, and we move on to where it's going to return 2 plus what we have here, 2 plus sum range of 1. And you'll see another sum range added to the call stack where num is now 1. So we are finally here, and this, our base case, is now true, which is great because we have to have rock bottom. We have to have an end of our recursion. Just like with Martin and the dog, the empty list was the endpoint. In this case, it's hitting 1. So we have return value of 1, and now you'll see this returns 1. So it's popped off the stack. And then that means that sum range of 2, which is waiting for sum range of 1, can now return. So it will pop off. And then finally, our initial functional call, sum range of 3, can return. And then we have finally our 6 return down here. And the last thing I'd like to show you is a very common error that occurs with Recursion called stack overflow. So this occurs when there's no base case or when you don't ever hit the base case. So if I got rid of this line, sum range is going to continue forever. If we did sum range of 3, it's going to proceed with adding sum range of 3 with sum range of 2 and so on. But as soon as we hit 1, there's no longer a base case, so that would return 1 plus sum range of 0. Excuse me. And then that in turn would return -1 and go down to -2 and would keep going, but not forever because our browser limit, or I think Chrome's browser limit, is 16,000 stack frames. So you'll see what happens when I execute this. Uncalled range error. Okay, so it doesn't say stack overflow. It says maximum call stack size exceeded. So I guess, in different browsers it would say, or in different languages it would say stack overflow, but yeah, this is a classic case of stack overflow. Thank you all for watching, and I hope you learned something about Recursion. Look forward to seeing you all next week.